Hello everyone, welcome to the circuits analysis video lecture series. In the last session, in the last consecutive session, we have seen from the preliminary concept up to the reduction of circuit analysis. So to conclude from this chapter, that means the introduction part, we are going to see the summary and quizzes, certain quizzes or problems which will be solved by the students or anybody who see or who use this video lecture. Okay, so we are going to see summary and quizzes on introduction to circuit analysis. As a summary, for circuit parameters, we have the current. Yeah, we have the current and we have charge, the relation between voltage and, current and charge. That means current, we know that is the flow of charge per unit time, and we can obtain from the given current, the charge should be obtained. And we have the voltage or EMF or potential difference. So this is the force or the pressure required to force the electron through the closed path in a circuit so that current will flow. Okay, and the other one is power. We have the relation between power, voltage, and current. So voltage times current will give us the power, and another formula which is I square R, which gives you the power. And the other one is V square over R, which gives us the power. And the other one is the energy, which is the product of power and time, or power is the time derivative of energy with respect to time. When it comes to circuit elements, we have two types of circuit elements. So the first one is the passive circuit element, and the second one is active circuit element. Under the passive circuit elements, we have the resistor, the capacitor, and the inductor. And the other ones, the active circuit elements, are voltage source, current source, battery, generator, op-amp, and the others. That means they can generate their own energy so that it can be used as a source of energy, whereas the passive circuit elements cannot generate their own energy. Either they store energy or dissipate energy. For the case of capacitor and inductor, they will store energy in their field. That means for capacitor, it is electric field, and for the case of inductor, it's magnetic field, so energy will be stored. And the other one is resistor, so which is responsible for taking energy and dissipate in the form of heat. So when we consider voltage source and current, so we have two types of voltage source: independent voltage source and the dependent voltage source. Okay, dependent voltage source, and also we have the current source as well, independent current source and dependent current source. Okay, so independent voltage source or independent current source, the sources which do not depend on the other circuit parameters, whereas dependent sources depends on the values of the other circuit parameters in the circuit. Okay, and with the third one, which is circuit laws, this is the Ohm's law. This is a very important fundamental laws which relates the voltage, current, and resistance. That means current is directly proportional with the supplied voltage, and the directly proportionality constant will be changed with 1 over R. So from this we obtain the relation between voltage, current, and resistance. That means voltage and current should be given by. So this is Ohm's law. And when it comes to Kirchhoff's law, okay, we have two types of laws. Kirchhoff's current law and Kirchhoff's voltage law. So this is used the sum of the current entering a node, which is equals to the sum of the current leaving the node, and the sum of the voltage around the closed path in the circuit will be 0. This is Kirchhoff's voltage law. Okay, when it comes to series circuit, we can consider two elements are connected in series if they have only one terminal in common, one lead of one is connected to only one lead of the other. That means, as you can see, this circuit is series connected resistor. The common point between the two elements is not connected to another current carrying element. So you can consider these elements are not connected in series. The current is the same through the series connected elements, and the total resistance of a series circuit is the sum of the resistance levels. Okay, so we can take this is the equivalent resistance. This is the equivalent resistance for series connected resistor. Okay, and the other one is the source voltage divided among the series connected resistors. Okay, and if any number of resistors with equal value of resistor are connected in series, so their equivalent resistor is directly obtained by taking one of the equal value of resistor and the number of series connected resistors. When it comes to voltage divider rules, this is a principle for series connected resistors. That means the voltage or the source voltage will be divided among the series connected resistors, and the resistor with the largest value will share the largest voltage from the source voltage. Okay, so we can have such type of relationship between for two resistors connected in series. Okay, so the source voltage will be divided among the R1 and R2. And if any resistors are connected in series, so totally we have the value of the voltage drop at any resistor will be given by this expression. Okay, and the circuit is voltage divider circuit, and the principle is the rule is the voltage divider principle. Okay, so under this portion you can solve such type of questions that will find the total resistance and the current type for the circuit given below. So you can solve by yourself, as we have solved similar examples in the previous consecutive sessions. Okay, and this is the second question in the previous summarized portions, and this is the third questions, and this one is the fourth question. So and also we have another fifth questions. So basically based on the principles of KVL, KCL, and Ohm's law, we can solve the above questions. Okay, when it comes to parallel circuit, two elements or branches or networks are in parallel if they have 2 points in common. So as you can see here, the two elements are connected in parallel because this terminal of 2 and this terminal of 1 are connected at point A, and the other terminals are connected at point B. So the two elements are connected in parallel. So the total resistance for parallel connected resistors is given by this expression, where N is the total number of parallel connected resistors, and the sum of the equivalent conductance will be the sum of each parallel connected conductance. Okay, if two resistors are connected in parallel, so their equivalent resistance will be obtained by using this formula, and if any number of resistors with equal value resistance are connected in parallel, then their equivalent resistance will be taking one value and divided by the number of parallel connected resistors. Okay, so that's very important. And we need to consider also for parallel connected resistors, the total resistance is always smaller than the smallest resistance in the parallel connected resistors. Okay, if three resistors are connected in parallel, then their equivalent resistance can be obtained by using this formula and the current divider rule. So the source current is divided among the parallel connected resistors in inverse proportion with their resistance values. That means for parallel elements with different values, the smaller the resistance, the greater the share of the input current. For two parallel elements of equal value, the current will be divided among, the current will divide equally. So two resistors connecting in parallel, so the total current will be shared by R1 and R2 by using this formula, where I is the total current supplied by the source. And from the parallel circuit, we can solve such representative equations, find the total conductance and resistance for the circuit given below. That's equation 1, and determine R1 for the circuit which is given by this network, and determine the unknown resistance given the fact that R2 is 5 times R1, and R3, which is half of R1. So for the circuit given by this, so you need to try these questions by yourself, okay, by yourself. When it comes to series parallel circuit, this is basically we are going to use reduce approach for determination of the total resistance or equivalent resistance and the total current, and we are going to use the return approach to find voltage across each element and current through each element. So some of the exercises on series parallel circuit, we have this certain portion of, for this circuit, certain portion of the elements are connected in parallel and the others are connected in series, so we can obtain the values of the elements, okay, the elements or the voltage across the element or current through an element. So this is the previous one is 1, and the second, this is the second representative equation which represents series parallel connection. Okay, then when it comes to delta Y transformation, we have basically the Y delta or delta Y transformation. So the first one is delta Y transformation. So that means we'll have the delta network at your hand. So you need to convert into the equivalent Y network. Okay, so to convert the equivalent or to obtain the equivalent Y network from the given delta network, always we need to draw a Y network inside the delta network. So as you can see here, the Y network is drawn inside the delta network as far as the delta network is given. Okay, so R1, it is obtained by taking the product of the covering resistance. So R1 is covered by RB and RA. So we'll take the product and divide by the sum of the 3 delta resistance. R2, it is covered by RA and RC. So R2 will be given by RA and RA times RC over RA plus RB plus RC, and R3 will be given by the product of RB and RC because the R3 is covered by RB and RC. Okay. When it comes to the delta Y transformation, we will have the the Y network, and we are going to determine the delta network. Okay. So for this case, we need to always draw. That means to convert from Y network to delta network. So always we need to draw the delta network outside the Y network. Okay. So using the previous derivation, just to summarize the previous derivation, we have the values of RA, we have the values of RB, and we have the values of RC, which is obtained by taking sum of products of the 3 Y connected resistors. Y connected resistors. Okay, that means RA, it is R1 times R2 plus R1 times R3 plus R2 times R3 divided by the opposite resistor for RA. That means the opposite resistor for RA is R3. Okay, and the second one, which is RB, so the numerator is not changed, only the denominator will be changed. So the same numerator value or expression divided by for RB, which is opposite by the opposite resistor for RB is R2. So the sum of product of the 3 resistors divided by the opposite resistor for RB, which is R2. And the third one is RC. So again, the same numerator expression divided by the opposite resistor for RC, which is R1. Okay. So using this, we can determine the expression. We can determine the values of RA, RB, RC to obtain the values of the delta network resistor from the given Y network resistors. Okay. So that's very important when we are facing a network which is neither connected in series nor in parallel. Okay, so we need to apply either delta I transformation or y delta transformation. Okay, so these are some of the exercises on delta I transformation. That means we are asked to evaluate are equivalent for each of the circuit given below. That means you can observe the network. That means for part A, some of the networks are connected in delta, or some of the connectors are connected in Y. So somebody may use this section to convert into Y network, or somebody may use this section to connect or to convert into delta network, or simply we can obtain the equivalent resistance without using the delta I transformation, because as you can see, this resistor and this resistor are connected in parallel. Okay, so their equivalent will be in series with the 2 kilo ohm resistor, and so the summation of the two will be in parallel with the 1 kilo ohm resistor. So we can use for every circuit, we can apply delta I transformation, whether the circuits are connected in parallel or in series. Okay, so this delta I transformation is a general case. So we can apply for any circuit configuration. We can apply delta I transformation. Okay, and the second one, you can observe, for example, the 12 ohm resistors, because as you can see here, this resistor and this resistor are connected at this point, and the other terminals of the two resistors are connected at this point. Okay, at this point. So we can say that this resistor and this resistor are connected in parallel. Okay, so we can have the equivalent resistance, or we can apply the delta Y transformation. That means this 4 kilo ohm resistor, this 12 kilo ohm resistor, and this 6 kilo ohm resistor will form a delta network. So we can draw inside a Y network so that we can obtain the equivalent Y network, so that the delta network will be removed from the network. Okay, so in this way we can determine the expression, the values of the equivalent resistance. For this case, determine V in the circuit given below. It says, okay, so first we need to determine, for this case, to give you some hints. Okay, that means to find the voltage across the 35 ohm resistor. First we need to determine, R equivalent, not the source terminal. So as you can see here, all the resistors are neither connected in series nor in parallel. So we definitely apply the delta I transformation or Y delta transformation to simplify or to obtain the equivalent resistance. Okay, then we can return back to the original network. So that means first we need to use reduction technique. Then after that we need to go back to the original circuit step by step, so we can obtain the values of the current passed through the 35 ohm resistor. So that current will be times the resistance value, so the voltage which is across the 35 ohm resistor will be obtained. Okay, this is another question. Find R equivalent and I in the circuit given below. So with the same procedure you can try it. That's all for the summary of the circuit analysis chapter 1. So based on the model examples what we have solved in the previous consecutive video lectures, we can or you can solve the provided quiz questions by yourself. Okay, that's all. Next session we are going to see by using simulation techniques, that means by using multism we are going to see how we measure voltage, current, resistance, okay, power, and the like. Okay, so that's all for this session. Thank you very much.
You can get the questions by using the link in the description.